question, the general illustration of letters which are SPDF. In actual, we have SPDF as the individual orbitals energy levels in a particular orbit or in particular orbits or in a particular orbit. We have the s orbital whose magnetic quantum number is 0. We have p, we have d, we have f, all of them consecutively. We have 0, 1, 2, 3, and proceeding to the next orbits having proper numbering in terms of magnetic quantum number. Also, so afterwards the definition, examples, illustration, journal. We have the characteristical feature application or general significance of magnetic quantum number, which expresses that how many, which is a question likewise, that how many F5p orbitals exist. So the answer to a question likewise will be -1, 0, 1. So we have 3 magnetic quantum numbers that exist for a 5b orbital. Alright, then we have the diagrammatic expression for general illustration of 5p orbitals according to magnetic quantum number. We have 5px, we have 5py, we have 5bz. One is parallel to the z-axis, one is perpendicular, and the other is just like 3D. Let us take another example for expression of magnetic quantum number explanation and also an example explanation. We here see a magnetic orbital quantum number. Again is the designation of the orientation or position of the orbitals of the sublevel. It indicates number of orbitals in sublevel or orbit or energy level. Can have integral values plus L to minus L. L is general representation of magnetic quantum number symbol. Letter we have here L. Let us take SPDF. We have 0, 1, 2, 3 respectively for each orbit or for each letter. Indicates number of orbits in sublevel. These are L numbers, and designates they can have integral values. The integral values are those, and letters are orbitals respectively. Afterwards, we have a question which asks us that how many 3D orbitals exist? How many 3D orbitals exist? So according to magnetic quantum number, we have 1, 2, 3, 4, 5 orbitals of 3D. We have 3D 5 orbitals. We have 5 orbitals of 3D level or energy level or orbit level that exists, which is according to L equals 2. That is the integral multiple you can see in here on the left side, and we have proper value for integral multiple of magnetic quantum number. So let us illustrate the diagrammatic representation of 3D orbital electron probability regions or 3D orbitals or clouds of 3D orbitals. We have L equal to 2, which means 2, 1, 0, minus 1, minus 2, or 0, minus 1, minus 2, and 1, 2, 5 3D orbitals exists in here. Afterwards, there are illustrations. So we have the first illustration. There's one, this one, this one, this one, this one. We have 5 complete illustration which expresses 3D 5. Then the spin quantum number can have only 2 values, which we know from the very before. One will be positive, the other will be negative. Alright, you can see in here that the one value is positive, which expresses one spin quantum number. The other is negative, which expresses negative quantum number. So let me draw it with a blue color. That plus sign represents one quantum number and negative sign represents the other spin quantum number in this case. Now let us move towards our general explanation about Pauli exclusion principle, which were described by a scientist, an image of whom is shown, who is standing near a board and lecturing, presenting something, or might be talking to his friends. But the Pauli exclusion principle states the Pauli exclusion principle states that no two electrons. Here it puts a limit on its own principle. The Pauli exclusion principle put a limit by mentioning two integral multiple, that no two electrons in an atom can have the same set of quantum numbers. Alright. Therefore, an orbital can accommodate up to two electrons. So, we expresses that an orbital, an energy level, or a proper subshell can accommodate, means can heap up, can accomplish, can altogether combine up to two electrons inside of its own self. And the other conclusion from the definition of Pauli exclusion principle will be that the two electrons in the same orbital must have opposite spins, which are spin quantum number, which I discussed from the very before of the definition of spin quantum number, that we have the positive sign and the negative sign expressing two types of quantum numbers, which expresses that one spin will be upward and the other will be downward. If one spin is downward, the other will be upward or will be heading in the upward direction, vice versa. Alright, so that's the definition of spin quantum number and its conclusion. Example include what are the quantum numbers of the circle electron. You can see in here that the circle electrons are being mentioned. One is that one is we have just one central electron. They ask us about the quantum number of the circle electron. So first of all, they had drawn some different orbitals according to the proper arrangement of orbitals in an atom, and they have drawn an arrow which expresses the energy levels of each orbital, which is exceeding from down to the upward direction. So they gave us a down arrow from the down side of the energy level, that what will be the quantum numbers of the central electron in this energy level. So we have all quantum numbers. We have the principal quantum number, alright. Then we have the azimuthal quantum number, alright. Then we have the magnetic quantum number. Then we have the spin quantum number. So the quantum numbers of the circle electron will be respectively to principal quantum number 0, azimuthal quantum number which expresses its s orbital position, and magnetic quantum number which is 0, and spin quantum number which is negative half of counterclockwise in the downward direction is taken half. So directly this one will have half, positive half values for its spin quantum number. So the whole expression for the quantum number of the circle electron will be likewise. Alright. Afterwards we have principal quantum number, orbital angular quantum number, magnetic orbital quantum number, spin quantum number written, and their restriction or limitation according to their principle or according to their rule, statement, definition, explanation, anyhow. So the restriction for the principal quantum number is that it will start from positive 1. Alright, it will start from positive 1, will exceed to positive 2, will exceed to positive 3, and so on, positive 10, etc, etc. Alright. And the other one, that is the orbital angular quantum number. In case of orbital angular quantum number, we have restriction that the L will start from 0. We will have the restriction that according to definition we will have L equals n minus 1 or L equals to 0, means L will start from 0, always then will exceed towards 1, or then will exceed towards minus 1. Alright. And the other limitation according to definition of orbital angular quantum number, that L will always be, orbital angular quantum number will always be less than principal quantum number, which is all clear from here. If you minus something from n, so L equals n minus 1, it will automatically decrease the original value of orbital quantum number. Afterwards we have magnetic quantum number. In magnetic quantum number describes the direction of the electron's probability region, electron approximately occurring, accomplishing chances of existing regions. So the restriction towards the magnetic orbital quantum number is magnetic quantum number is equal to L, and that will exceed towards minus L, which are integral values of the magnetic orbital quantum number. Afterwards, so that's the general mathematical expression or symbolic expression of the magnetic orbital quantum number. Then we have the spin quantum number, which indicates the electron spin. The spinning motion, like the spinning motion of Earth around its own axis. So this spin quantum number expresses the indicates give the prediction indication of the electron spin about its axis, due to which we have a restriction. Likewise, that the spin quantum number may be positive half or it may be negative half. And in page 13 by 19 out of 19 page, we have magnetic quantum number, orbital magnetic quantum number equals 0, minus 1, minus 2, 1, 2, which is for exactly for 3d orbital, and for 5p orbital we have 1, 0, minus 1, and for 1s orbital we have ml equal to 0. For n equals to 3 we have this condition. Alright, you see, and we have this condition. We have this one orbital, this one orbital, this one orbital. It is clear up to that. Moreover, the orbital quantum number for 3d orbital is that one. So we have 1, 2, 3, 4, 5, which are also 1, 2, 3, 4, 5 orbital energy levels or probability of finding or existing electrons in there. Alright. Afterwards we have the 3s orbital generally, whose value is 1 for as a principal quantum number. So it's a 1 shell, which is described in here, you can see. Alright. Afterwards we have 2p orbital, whose existing orbitals are those, and their principal quantum number is mutual quantum number, orbital magnetic quantum number are being given in there. Alright. And for this one we have sp, okay, we have sp2, or sorry, we have sp in here, which are for this explanation, that is not belonging to a second one expression. The second one expression just expresses this expression, for whom we have 0 orbital magnetic quantum number, that is 2s orbital, and for 1s orbital we also have 0 orbital magnetic quantum number, LL also equal to 1, 0. We have s also equal to 0. We have n equal to 1, because there is only one quantum number which is expresses principal quantum number equals to 1, which because we have one energy level or one shell or one probability of finding electrons in there. Alright. So the overall more explanation to the point here is that the mutual quantum number or orbital quantum number, in this case, in all those situations, we have energy exceeding, you can see, in the upward direction. So when we have the orbital quantum number exceeding, so that means the energy level of electron is also exceeding in there. Alright, so from here to here we have the energy difference, some proper energy difference which will exactly have positive proper value. Alright, then we have from here to there, which is also a positive difference in energy. Alright, then we have from there here to there, which is also a big difference. Let's say that is energy difference 3, also positive. So summing in back all the energy levels from here to here and from here to here and from here to here, which gives us that value, which will be del E equals to sum of del E1 up to del E3. So that was just general energy difference according to the orbital magnetic quantum number. Now on the page 15/19 you have a situation. Here we discuss quantum numbers related to periodic table. So periodic table, which is mainly based, in which groups are mainly based or elements are based on electronic configuration. So let us describe electronic configuration. Electronic configuration is a general description or expression to the electronic structure of an atom by listing the occupied sublevels and number of electrons in each sublevel. Alright, the electronic structure of an atom by listing the occupied sublevels and the number of electrons in each sublevel, in each occupied sublevels being occupied by the electronic structures of electrons. That is the general electronic configuration. We have 3 points in here: electronic structure, occupied sublevels, and the number of electrons in the same occupied sublevels or in each sublevel. That is done. Move towards the quantum number related to periodic table. Experimentally, only the quantum numbers n and l. Sorry about a little disruption in my phone. Experimentally only the quantum numbers n and l can be determined for an electron, and the remaining two orbital magnetic quantum number and spin magnetic quantum number can be generally theoretically written or can be theorized according to their atom, element or sample given for proper quantum number configuration. Afterwards, relating quantum numbers to periodic table, we have another general situation that what will be the quantum numbers of the circle electron of an up arrow. The example which we have done on 12/19 page were for a down arrow. Quantum numbers for an up arrow will be likewise that n will be equal to 3 for an up arrow. In this case, azimuthal quantum number equals 1. M will have 3 values. Also, the spin quantum number will have a positive half value, and there we have 3 possible correct answers for it. The quantum numbers will be 3 1 minus 1 plus half, 3 1 0 plus half, 3 1 plus half plus half. Afterwards, the professor has given me an illustration. I called for it myself, and I gave it a name of the fake, I will say the non-existing or the unseen atomic structure. So, if you could see an atom, how would it appear? So the case here is that we will be saying that will be an orbital. Let me mention, will be predicting or will be asking that, let me sign it blue, that is an orbital having electrons with charge like this and having those number of electrons or having those spin or magnetic quantum numbers. So we can say that properly. Alright, afterwards we will be saying that is the nucleus which is being bound by this structure composed of protons and neutrons, etc. Or would we be saying that this will be the structure of all of the entities localized inside an atom. So we can't say all that properly. But the quantum theory mainly predicts, indicates. In the summary, we will say that quantum theory predicts the condition, situation, circumstances of electrons, and circumstances will include the probability of finding an electron in such a situation, the certainty, which is the error in proper probability of a proper electron being localized or delocalized or having proper quantum numbers. The quantum numbers just tell us about the conditions of an electron. That is just the simple definition of a quantum theory, in which we have 2 points: generally probability and uncertainty. So in this diagram you can see in the first image we have 200, then we have 300 hydrogen wave function. We have proper hydrogen wave function in here, whose formula is also being given. Alright, you can practice that or can call on comment telling me I'll explain it if you ask. Situation. In the second situation we have this one, this one, this one. Alright. In the third situation we have another expression, that is that one, that one, that one, that one. Alright. And in the fourth situation, that is that, that, that. So you can see that is an X-ray type or a color tomography type illustration of the existence of electrons around an atom or the energy levels, or that is just the condition circumstance of an orbit or the place where electron can be found. Means the orbit is the basic place where electron can be found. So these are 5 other conditions. Afterwards we have this one, this one, that one, that one, that one, which is also the probability of existence of an electron. Alright, so that is done.